We can also change or update an existing stack element using stack operations. For example, consider the following stack 4, 5, 7, 8. Suppose that we want to change the element at index 2 to 6. First, we pop until we get to index 2. Then we replace 7 with a new value. Finally, we restore the popped elements. This is very similar to the insert operation, but instead of adding a new element, we are replacing an element. Here's a demonstration. We popped 4, then 5, and when the index reached 0, we popped and removed 7. Then we pushed 6, and then we pushed 5 and 4 back into the stack. Notice that the push order is the reverse of the pop order. As we can see, the result of setting index 2 to stack 4, 5, 7, 8 to 6 is 4, 5, 6, 8. As with the insert operation, we first pop elements from the stack as we decrease the index. When the index reaches 0, we replace the top element with a new value and dump the popped elements back into the stack. Let's now try to precisely describe this operation. We need to keep track of the popped elements, so we first convert the set operation to the set element compute function, whose input is the stack, index, the new value, and the popped elements. Here is the conversion. The result of setting index I of stack S to value V is equal to the output of function setElementCompute, where input stack is also S, index is also I, value is also V, and the pop stack is empty. We can describe the behavior of the setElementCompute function in two properties. Output of function setElementCompute, where input stack is AB, index is I, value is V, and pop stack is Z, is equal to the output of the same function where input stack is B, index is I minus 1, value is V, and pop stack is AZ. Property 2 says that the output of function setElementCompute where input stack is AB, index is 0, value is V, and pop stack is Z, is equal to the result of dumping stack Z to stack VB. Property 1 says that the output of the setElementCompute function will stay the same, even if we move an element from the stack to the pop stack, as long as we also decrement the index. For example, let A be 3 and B be the stack 4, 5, I be 1, V be 9, and Z be the empty stack. Then we claim that the output of the function setElementCompute, where input stack is 3, 4, 5, index is 1, value is 9, and the pop stack is empty, is equal to the output of the same function where the input stack is 4, 5, index is 1 minus 1, value is 9, and the pop stack is 3. Let's check whether the left side of the equal sign is equivalent to the right side. We know that the output of function setElementCompute, where input stack is 3, 4, 5, index is 1, value is 9, and pop stack is empty, is equal to the stack 3, 9, 5. We also know that the output of function setElementCompute, where input stack is 4, 5, index is 0, value is 9, and pop stack is 3, is also equal to 3, 9, 5. Since both sides are equal to the stack 3, 9, 5, the left expression is equal to the right expression. Property 2 says that when the index is 0, we can obtain the output by pushing V to the original stack and dumping the pop stack to the original stack. Let's use these properties to evaluate the result of setting index 1 of stack 11, 19, 17 to value 13. First, we use the conversion property to claim that the result of setting index 1 of stack 11, 19, 17 to value 13 is equal to the output of function setElementCompute, where input stack is 11, 19, 17, index is 1, value is 13, and pop stack is empty. Now let's use property 1 to claim that the output of function setElementCompute, where input stack is 11, 19, 17, index is 1, value is 13, and pop stack is empty, is equal to the output of the same function, where the input stack is 19, 17, index is 1 minus 1, value is 13, and pop stack is 11. Notice how 11 was moved into the pop stack. Since 1 minus 1 equals 0, we can substitute 1 minus 1 with 0. Since index is 0, we can use property 2 to claim that the output of the function setElementCompute, where input stack is 19, 17, index is 0, value is 13, and pop stack is 11, is equal to the result of dumping stack 11 to stack 13, 17. Notice how 19 was replaced by 13. And from the dump lesson, we know that the result of dumping stack 11 to stack 13, 17 is equal to the stack 11, 13, 17. Now we can use the transitive property a few times to conclude that the result of setting index 1 of stack 11, 19, 17 to value 13 is equal to the stack 11, 13, 17.